Hi, now that we know what re-entrancy attack is, so let's implement our withdrawal balance with this ideology in our mind. First, I'm going to import ReentrancyGuard here. I'm using the same path, but instead of utils, I'm going to security. Then I'm getting to ReentrancyGuard.sol contract. Here, I'm going to say this is ReentrancyGuard, and then we are going to go below to our functions. First, I'm going to define my function withdrawBalance, and we are going to have amount as the parameter. It's going to be an external function, and I'm going to say non-reentrant here. After this, first we are going to require is user so that we can see if we have the user or not. We are going to check message.sender. If not, we are going to say user does not exist. Next, we are going to get the balance of the user. After this, I'm going to say require balance is bigger or equal to amount. If not, we are going to say insufficient balance to withdraw. After we make our checks, we are going to say unchecked here, because if you remember from the above function, since we did the check here for the underflow, we do not do this again here. I'm going to say users message.sender so I can get the current user balance. I'm going to subtract it with the amount. After that, we are going to send the tokens to the user. For this, we are going to create our return tuple. The second item will be empty since we don't use it here. I'm going to say message.sender.call, and I'm going to say amount as the value here, and our message will be empty. Next, we are going to say require success so we can check if our transfer was successful or not. If not, we are going to say transfer failed. After we send the token and we make our check, we can emit our event. I'm going to say balance, withdraw, and message.sender, and amount as the parameters. So let's review our function quickly. First, we set non-reentrant here so we can make it resistant to re-entrancy attack. Then we checked if we have the user. Then we got the balance, and we checked if the balance is more or equal to the amount so that we can say unchecked here. After that, we send the token and we required success so that we would know that transfer did not fail. If it failed, we said transfer failed here. After that, we know that we are successful with our transfer so that we can emit our event here. Next, we are going to have withdrawOwnerBalance function. For this, I'm going to say function withdrawOwnerBalance. We are going to give amount as the parameter. It's going to be external and only owner. We are not going to use non-reentrant here since we are not concerned with re-entrancy attack from the owner. We are going to say require total payments bigger or equal to amount so that the owner cannot withdraw amount more than the total payments made to the contract. If not, we are going to say insufficient contract balance to withdraw. After we make our check, we can send the tokens to the owner, and this will be the same ideology as before. We are going to get the tuple and we are going to say owner.call, and here we are going to pass the amount as the value, and our message section will be empty. Next, we are going to require success, and if anything is wrong, we are going to say transfer failed. After this, we are going to say total payments minus equal to amount. And for this, instead of like this, since we make the check here, total payments is bigger or equal to amount, we can say unchecked here, and we can copy this there. Now let's see what we did. It's very similar to the function above, but here we did not add the non-re-entrant check since we are not concerned as we talked. Then we updated the total payments here, so the next time the owner wants to withdraw tokens, we would know that we updated the total payment so that it's going to show the correct thing. In the next video, we are going to implement our query functions. That's all for this one. Thank you and see you on the next one.